A water molecule is made up of two hydrogen atoms bonded covalently to an atom of oxygen. Water is an example of a polar covalent molecule. The oxygen atom exerts more pull on the shared electrons than the hydrogen atoms, resulting in a slight increase in negative electric charge at the oxygen end, and a slight increase in positive charge at the hydrogen ends. The polar nature of a water molecule gives it the ability to form hydrogen bonds with other water molecules. The force of attraction between one of the slightly positive hydrogen ends on one molecule and one of the lone pairs of electrons on the slightly negative oxygen end on another molecule can stick the two molecules together in what is known as a hydrogen bond. Hydrogen bonds between water molecules are weak compared to covalent bonds within a molecule, but overall are still a significant factor in explaining certain properties of water, such as the relatively large amounts of heat required to melt ice and boil liquid water, and its high melting and boiling points relative to other similar molecular substances. A water molecule can form hydrogen bonds with up to 4 other water molecules, arranged at the vertices of a tetrahedral structure. Below 0 degrees Celsius, water exists in its solid state, which we know as ice. In crystals of ice, these tetrahedral structures are connected together by hydrogen bonding to produce an extended pattern of repeating hexagonal rings of water molecules, stacked in sheet-like layers. This arrangement also accounts for the 6-sided symmetry of snowflakes. If ice is heated until it is 0 degrees Celsius, it begins to melt, forming liquid water. As the kinetic energy of the water molecules increases, some of the hydrogen bonds break, and water molecules are displaced from the fixed positions they occupy in the crystal lattice. At temperatures above 0 degrees Celsius, the relatively open hexagonal lattice structure of ice collapses entirely, and the water molecules jostle more closely around each other. Liquid water is actually about 10% denser than ice, which is why ice floats in liquid water. In liquid water, hydrogen bonds still exist between water molecules, but they are constantly breaking and reforming due to the increased kinetic energy of the water molecules. At standard atmospheric pressure, water boils at 100 degrees Celsius, forming the gas called steam. As liquid water is heated, some of the water molecules acquire enough kinetic energy to break free of the hydrogen bonds binding them to other water molecules in the liquid, and they escape into the atmosphere as water vapor. Even at 100 degrees Celsius, a significant amount of heat is required to break all of the hydrogen bonds, in order to convert all of the liquid water into steam. Above 100 degrees Celsius, water molecules have too much kinetic energy to form hydrogen bonds with other water molecules. In similar fashion to the particles of other gases, they move around more rapidly, spreading further apart, and when they collide, they simply bounce off each other,